Okay, so today we'll be studying about planes. You have already studied about vectors and you have already the concepts of vectors, cross product, dot product, how to find the magnitude of a vector and all those things. So those are the prerequisite for studying plane. Knowledge of vectors will be there. Okay. So knowledge of vectors is required before studying planes. Right. And what are the things which we will learn in planes? What is a plane? How can we determine a plane in space? Obviously, we are talking about 3D figures. So, what are the attributes which can define a plane in space uniquely? So, some aspects are involved. We'll discuss about that. And then, we'll be deriving some equations of planes. And based on that, you will be solving some questions also. So, first of all, as I said, knowledge of vector is very much required, otherwise plane is difficult to understand. So, I believe you people have the knowledge because we have done this vectors, you have attended my lectures earlier also. So, let me come to planes. Now, even this board is a plane. So a plane can be consisted of only two dimensions, x and y. So x-axis and y-axis, that determines a plane. Y-z will determine a plane, y-z plane. Z-axis and x-axis will determine the plane, z-x plane. If you see in this room only, if I take this side the length, this is the width, and this is the height. So if we consider them as x-axis, y-axis and z-axis, and the corner of the room at the bottom, if we take it as the origin, then since this is consisted of x-axis and z-axis, this will be xz plane, y and z will make the yz plane, and similarly z and x will make the zx plane. So first of all, a plane is determined by two axes. It is consisted of two axes. Any two, xy axis will determine xy plane, yz axis will determine yz plane, and zx axis will determine zx plane. Right. So plane as it is not three-dimensional, it is two-dimensional. But whenever we have to describe something in space, that is three-dimensional. Because if you have to describe something in plane, suppose if I have to find the location of a point, this point, then since if it is x-axis and y-axis, and if I give the x coordinate and y coordinate, if these two are known, then this point can be determined uniquely in this plane, right? But if the point, this point, suppose if it is here, then some height is also involved. So we require the third dimension also. In that case, z-axis will also get involved. So plane is as such is two-dimensional, but when the plane, we have to describe the plane in space, then that space, there the coordinates which will be required, they are of three-dimensional. So let us come to discuss the factor which will determine the planes uniquely in space. But before that, some of the things, let me remind, which will help you in understanding planes. In straight line we have done, through a point how many lines can pass? Infinitely many lines can pass through a point. If there are two given points then how many lines can pass through two given points? Only one line. Two given points determines a unique line. If you have 3 points, but if they are collinear, then they will also determine only one line. So even if you have many points, and if all of them are collinear, they will determine only one line. Similarly, through space, suppose there is a point here. So through this point, one plane can pass like this, another can pass like this, one can pass like this, one can pass totally vertical. So through a point in space, infinitely many planes can pass. But then, how can we determine the plane uniquely in space? So for that, the 3 things are required. The first one is, that is called, the first attribute which will determine a plane uniquely in space is, if the plane is passing through a given point, if the plane passes through a given point, and if its perpendicular distance, from a fixed origin, from a frame of reference which we call origin, from a fixed origin is known. Okay, so let us concentrate on this. What is this? It's saying if the plane passes through a given point, and if its perpendicular distance from a fixed origin is known. What do they want to explain here? It's a 3D figure, but since the third axis, this is x-axis, y-axis and z-axis, but z-axis is not like this, it's not in the plane, it's like this. Okay, and suppose there is a plane. Let us consider a plane like this. So 3D figure I am drawing on a board, so obviously it's difficult, but you should try to imagine. So actually the plane may be something like this or this, right? And if the perpendicular distance of this plane from a fixed origin is known, this is the fixed origin, and let this perpendicular distance is d, and the unit vector along this direction is n cap. So we can write this perpendicular OM. OM is the perpendicular to a plane. Plane may be passing like this, and this is the perpendicular distance. So this is known. dn cap is the vector which will give the direction of the perpendicular, and let the plane is passing like this. But actually, at perpendicular, the plane can pass, many plane can pass. It's not just one, right? At this perpendicular distance, one plane may go like this, another may go like this, another may go like at some other angle. But with this, it will be making 90 only. So the orientation of the plane may be different here. It's like this, okay? One may go like this, one may come down like this. So at different angles. So right now this plane is not defined uniquely. But if we say that only one and only one plane is passing through this, so for that what do we fix? Suppose the plane is passing through a given point, and let that point has the coordinate x1, y1, z1. Try to get it properly. I'll just take the example. This plane is passing through this given point x1, y1, z1, and this is the perpendicular to the plane. Now the plane will be defined uniquely. Only one plane can pass through this point, because, for example, just you see, in this book, suppose this point M is the point through which the plane is passing. So M point is here. Through this the plane can pass like this, it may also pass like this, it may also pass like this at different angles, many plane can pass. But if I fix the perpendicular distance of this point from a fixed origin, if this distance is fixed, then only this plane can pass through this point M. Why? Because suppose if another plane we consider, then the angle will be changed. The angle will not be 90. The angle will get altered. So it will be less than 90 or more than 90. So if a plane is passing through point M and we have a perpendicular to the plane from the origin is somewhere here. So from the origin, if the perpendicular is known and the point is known, then only one plane can pass through it. If you consider, if you are thinking in your mind that no, even the plane can pass like this, but then as I said, the angle will change. Angle will not remain 90. So you have to follow both the constraint. So that's why we have said that the angle which it makes, it is at a perpendicular distance d. So if this angle has to be 90 degree and if the plane has to pass through this point M, then it has to be a unique plane. You may think, you can imagine different ways, but if this perpendicular is not fixed, because this perpendicular will keep the plane in a fixed direction, this angle cannot change. It will keep it in a fixed direction. The moment you change that, you turn the plane, you tilt the plane, inclination will change and then angle will not be 90. So through a point, given point, only one plane can pass, and if its perpendicular distance from a fixed origin is known. So this was the first one. Second is, a plane can be determined uniquely in space if it passes through a point, if it passes through a point and its distance, a plane can be, if it passes through a point and let's change it like this, if it passes through a point and it is perpendicular to a given vector, it is perpendicular to a given vector. Now, how is it different from the first one? Just try to understand. The plane is passing through a point. Let again, the point is M. The plane is passing like this. Now, point M is here. So, through this point, the plane can pass like this also, like this also, like this. But again, they have given it, and it is perpendicular to a given vector. So, in the earlier case, the perpendicular was from a fixed origin. In this case, the perpendicular is not from a fixed origin, but a perpendicular plane is perpendicular to a given vector. So again, this time it is not from the origin. The plane is passing through the point M, and there is a vector which is perpendicular to the plane. It may lie anywhere on the plane. The vector, a vector can be displaced parallel to itself anywhere. We have discussed it in vector. So in this case also the plane will be determined uniquely because this vector, suppose this is the perpendicular vector. Plane is perpendicular to the vector, so you can say the vector is perpendicular to the plane. Plane is perpendicular to this line, so we can say this line is perpendicular to the plane. Now this is a vector quantity, so its direction is fixed. So it is not going to change. And the plane has to pass through the same point M. So even there has to be a unique plane, only this one. Right? Suppose if you say no, through point M, plane is passing like this, but then this vector has to be at 90 degree. So if it passes through a point and it is perpendicular to a given vector, then also the plane can be determined uniquely. It's all about imagination. 3D, whenever you have to study 3D mathematics, you have to imagine because it is related to space. Once again I will say this is point M. Through this the plane is passing like this and a perpendicular to the plane is known. So again in this case also you cannot turn the plane. The moment you turn, the angle will be different. So you can think, what is the difference between the first one and the second one? The first one is from a fixed origin, perpendicular from a fixed origin. But in the second case, the point may be anywhere, plane is passing through that and its perpendicular vector is known. So through that only one plane can pass. Now let me discuss the third one, third aspect. Plane is passing through. Third one is plane is passing through three non-collinear points. (3D) requires lots of imagination. So suppose, let's talk about this board. There are 3 points which are non-collinear. They do not lie on the same line. Everybody knows about that. So through these 3 non-collinear points, obviously only this plane can pass. This board on which I am writing, only this plane can pass. Suppose we have 3 points in space. One point is here, another is here, and one more point somewhere here. So again you can think about a triangular lamina which can pass like this. So whenever you have 3 non-collinear points anywhere in space, only one plane will pass through them. So these are the 3 things, 3 attributes which defines the plane uniquely in space. Last one, as I discussed, through 3 non-collinear points, only one plane can pass. First one was the perpendicular distance of the plane from a fixed point of reference is known, and it's not only perpendicular, even its direction is known. And secondly, the distance is known and direction is known, so the only one plane will pass through this. The second one I had told you that the plane is passing through a point and it is perpendicular to a given vector. So whenever you make a plane perpendicular to a given vector and there is a point through which it is passing, so no other plane can pass through the same point and can be perpendicular to the same line, same given vector. So that also determines a unique plane. And whenever we have 3 points in space, anywhere in space, then through those 3 points only one plane can pass. So these are the 3 attributes of a plane passing. Now we have to, since we are studying the plane, here we have discussed that how the plane can be determined uniquely in space, but we have to find the equations of plane. To study in depth about the plane, you have to find the equation of different types of plane. So I am going to discuss the first one only. Everyone just concentrate on this. Suppose this is the plane which is at a fixed distance d, and the vector along this is dn cap, and we have to find out the equation of this plane. Now children, you are already aware, whenever we have to find the equation of a line, say the standard equation of a line is of the form ax plus by plus c is equal to 0. So while writing the standard equation of anything, you require the general points. General points are x and y when you talk about a plane. When we talk about 3D, then even z coordinate will get involved. So equation of a plane, if you want to find out, obviously you want to find out in terms of x, y and z, because even the third dimension is involved. So suppose there is a point P here, which has the coordinate x, y, z. This is the point P. I will mention its coordinate outside. P has the coordinate x, y, z. This point P, right? This has the coordinate x, y, z. And let its position vector be r vector. This is why I told you in the beginning, knowledge of vector is very much required. Position vector are those vectors which are directed away from a fixed origin. This is the fixed origin, and this vector is directed away from this. This point was P I have taken. So its position vector I have taken as r vector. Now suppose if I join MP vector. So look at the triangle OMP. In triangle OMP, again vector will come the same. We have already done this. Triangle law of vector addition. Many of you must have already thought about this. Triangle law of vector addition. Now see what happens in this triangle. Two of the sides are in the same orientation, OM and MP. Orientation is like this. So this is clockwise orientation. This is clockwise. And OP is in the opposite orientation, anti-clockwise. This orientation is anti-clockwise. So I have explained you many times in vectors. Then this will be the resultant of these two vectors. And if we use triangle law of vector addition here, that means sum of these two sides will be equal to this. OP will be the resultant of these two vectors. Now in physics, if you connect it with physics, then you have studied in physics also. Suppose one force is acting on a body. There is a body here. One force F1 is acting on the body like this. Another force is acting, F2 is acting on this direction. Then in which direction the body will be moving? Suppose if the resultant force is able to move the body, then in which direction the body will move ultimately? So ultimately the body will move in this direction, which is the third side of the triangle, which is given by the third side. We call it closing side of the triangle. So if one force F1 acts in this direction, F2 acts in this direction, then the resultant will act in the direction of the third side. This is what I had explained you in vectors. Right? All these things have got lots of application in physics, in sciences. Right? So here also, this is, suppose you can assume this is F1 force, this is F2 force, the resultant force will be this R. So we can write here, in this case, in triangle, this triangle OMB, by using triangle law, what can you write? OM vector plus MP vector equals OP vector. Now, OM vector, you have this OM vector, if we give it E vector, if we give it A vector, right? But actually we already, you can also denote it by this only, dn cap. So dn cap plus MP vector we have to find out, and this OP vector is R vector. So from here if you want to get MP vector, this is R vector minus dn cap. So MP vector we got R vector minus dn cap. Now if we fall back to vectors again, because entire 3D is vectors only. So let us remind you about this concept. A vector dot B vector we had done AB cos theta. If you all of you remember, AB cos theta. It's a scalar product. We call it dot product. Now this is magnitude of A, this is magnitude of B, and theta is the angle between them. And as we have done in vectors, that if theta is 90 degree, then cos 90 had the value 0 and the dot product is 0. So we are going to use this fact that dot product of two vectors is 0 whenever they are perpendicular to each other. So similarly here, just to see, this MP is a line on this plane, MP is a line on this plane, and I said this dn vector is perpendicular to the plane, so it will be perpendicular to MP. I will make this concept understand. Please think, this board is the plane, this entire board is a plane, and suppose I have taken 2 points M and P somewhere. So if this is perpendicular, this chalk, you can consider this perpendicular to this board. Then if I join this line, so it will be perpendicular to that line also. At any point of the line, it will be perpendicular to that also. It does not matter whether the point P is here or if the point P lies here. then also there is no problem because it is perpendicular to that plane, so it will be perpendicular to every line in any orientation. To every line this will be perpendicular. In whatever orientation you draw the line, it will be perpendicular to all of them. So say in the same scenario, this is the perpendicular vector. This OM is perpendicular to the plane, mind it. OM is perpendicular to the plane. So OM is also perpendicular to MP. OM will also be perpendicular to this line MP. As the same example here. This chalk I am saying is perpendicular to the plane. So it will be perpendicular to every line of the plane. So OM is perpendicular to MP, and we are going to use this concept that whenever two vectors are perpendicular to each other, then their dot product is 0. So OM vector dot MP vector will be 0. Why 0? Because they are perpendicular vectors, perpendicular. Now OM vector you will write as dn cap dot MP vector, we have already got this value, r minus dn cap is equal to 0. So let us write it n cap r minus dn cap. This is 0 upon d, so that will be 0 on d. Now let's use this, multiply this in the form of dot product only. This is r vector, right? Yeah. So r vector minus d. Again the concept of vector has come. N cap, this is a scalar, so d will keep outside. N cap dot n cap, and this is n cap dot r vector is equal to 0 upon divided by d is 0. So, and we also know children that a dot b, this is equal to b dot a, because b dot a also has the same value, that is mod of b. It's a scalar product. So BA cos theta, A dot B and B dot A have the same value. But you can't do this in cross product. I have already told you A cross B is not equal to B cross A. A cross B is equal to cross product of two vectors is equal to negative of it if you reverse the order. But dot product is the same. So here it is n vector dot n cap dot r vector minus this d n cap dot n is equal to 0. Once again, A dot B is AB cos theta, right? I am trying to get the value of this, so just have a look at this once again. If I write A vector dot A vector, then according to this formula, it should be magnitude of A into magnitude of A into cosine of the angle between A and A. Now, if A vector is like in this direction, directed like this, another A vector will be the same only. So what is the angle between them? Angle between the same vectors will be 0 because they have the same direction. So this will be cos 0, and cos 0 has the value 1. So in that case, what do we get? A dot A is equal to modulus of A whole square. Because cos 0 degree, that will give you the value 1. So this is mod of A whole square. So similarly, suppose if I have to get n cap dot n cap. Now you know n cap is the unit vector. N cap is the unit vector. They have the magnitude 1. So it will be magnitude of n cap like this, and again into magnitude of n cap, and into angle between them is cos 0 degree because they are in the same direction. Right? In place of A, n cap, other A, so other n cap, and angle between them. And as you know, they have the magnitude 1, which are called unit vectors because they have the magnitude 1. And cos 0 also has the value 1, so this is 1 only. So in place of n cap dot n cap, I am going to use 1. Okay? So this calculation I will take further. This I just wanted to remind you with these formulas I will be using here. N cap dot n cap I will be using 1, and A dot B and B dot A is the same, so I will reverse the order here. That does not matter because in standard form this is the proper vector, this is unit vector, so this is written first. Even if you can write it like this, there is no problem. So let me write it r vector dot n cap minus d, and as you have seen here, n dot n has the value 1 is equal to 0. So r vector dot n cap is equal to d. This is the vector equation of a plane. Which plane? Which is at a perpendicular distance of d units from the origin. This gives you the perpendicular distance from the origin. So always while solving the question, you should keep in mind it should be positive because it's a distance. So r vector dot n cap is equal to d, and this is the vector equation of the plane. Similarly, we can convert this. We can get another equation in Cartesian form. Cartesian means when we relate there, we write their coordinates. Right? We can write this r vector as xi cap plus yj cap plus zk cap, and n cap unit vectors are written as with the help of their direction ratios as explained earlier in earlier classes. So you can write it as ai cap plus bj cap plus ck cap. Even you can write it as li cap plus mj cap plus nk cap unit vector. In fact, we should write it in that term only. And if you find their dot product, I'll just complete the Cartesian form. This is the vector equation of a plane, which has a position vector r, which is passing through at a perpendicular distance d units, and the perpendicular is in this direction n cap, and r is the position vector of the general point. So this vector you can write as xi cap plus yj cap plus zk cap. Dot unit vector is always, as mentioned earlier, is written as li cap plus mj cap plus nk cap is equal to d, and you already know there that this L, M, N are the direction cosines of the line. Direction cosines of the line. So let me remind, these are the cosine of the angle which a vector makes with the positive direction of x-axis, y-axis and z-axis. This we have discussed in vectors, and even in 3D, three-dimensional geometry, when we were doing lines, then also we have discussed. And you also know dot product. I dot I is 1, but I dot j is 0. I dot k is 0 because the same thing. Come back here. I dot j, I had the magnitude 1, j had the magnitude 1, but angle between I and j. So as you know, I cap is the unit vector along x-axis, j cap is the unit vector along y-axis. So obviously the angle between them will be 90, and the moment theta gets 90, this becomes 0. It will make the entire thing 0. So I dot I will be 1, j dot j will be 1, k dot k will be 1, all the others will be 0. So we have to multiply directly. Even this I don't have to explain here in detail because you already know that this is how we find the dot product. So this will become nx plus my plus nz is equal to b. Now this is called the Cartesian equation of the plane because the coordinates are involved in this, and the first one is called the vector equation of the plane. So based on the first constraint, we have got the equation of a plane, and so grasp these concepts properly, revise vectors again to understand it properly, and in the next class we will solve questions based on this equation and these concepts. You will get even more equations based on the other constraints. Thank you.